This is a video on vectors. You're going to see vectors a lot. So let me ask you a question here. This is like a first grade question, right? What's 1 plus 1? Most of you are going to say 1 plus 1 is 2, right? Well, if you said 2, you're only partly correct. Let's say you take 1 step forward and 1 step backwards. How far have you traveled from your starting position? It's not 2 steps, it's actually 0. And that's because some quantities have a direction to them. And direction is really important. And we call these vectors. So vectors have a direction. They also have a size to them, and the size of the vector is called the magnitude. And you'll see this come up sometimes too. Now sometimes you'll have quantities that have a size but not a direction. And those are called scalars. So they only have a magnitude. And that magnitude usually includes units. So for example, when we talk about time, something is 2 seconds. 2 seconds doesn't have a direction to it, it just has a size. So it actually is a scalar. So if you add 2 seconds to another 2 seconds, that's always going to get you 4. But if you're talking about distances, for example, well, those distances, they might have a direction to them. So if it has a direction to them, we actually call it displacement. So displacement is like distance, but with a vector. Now we have a scalar equivalent to that, and that's just distance. So if you take 2 steps, what's the total distance you've traveled? 1 step forward and 1 step backward. It's still 2 steps. But what's your displacement? How far are you from the starting point? I'll say far from the starting point. It's 1 step forward and 1 step backwards. You're back at the starting point, so your displacement is 0. I mentioned speed and velocity before. For example, velocity is a vector. Acceleration is also a vector. Velocity is like speed, but with a direction. Now, many of you have a speedometer in your car. Speedometer measures how fast you're going, but it doesn't tell you your direction. If it told you your direction, it would be like a velocimeter or something like that. But the speedometer tells you your speed. The velocity is like speed, but with a direction to it. So it could be 60 miles an hour northeast, and that would be velocity. 60 miles an hour would just be your speed. You're going to see others as well when we do energy and work. That's actually a scalar. Some things like momentum, impulse, those are vectors. Forces are vectors. So there's certain vector quantities and certain scalar quantities, and it's important to keep them in mind because when you're adding vectors, for example, they can be totally different than adding scalars. No longer is 1 plus 1 equal to 2 all the time. Oftentimes it's not. I'm going to give you an example of how to add some vectors right now. And there are a few different ways to add vectors, and you're going to get a chance to see how to add vectors in class and then also in one of the labs. But because a vector has a direction to it, we can write it as an actual graphical representation. So this could be a vector. And we might even put a scale on it, and we might say that scale is 1 centimeter on the paper equals let's pretend this is force. and we're dealing with newtons, 1 centimeter on the paper is 2 newtons for this vector. So we can measure the length of this vector, and we can see that it is in fact 47 centimeters, and each centimeter is 2 newtons, so that means it is 94 newtons. So that's 94 newtons. Now we might know the direction of this vector. This direction, let's say it's 30 degrees, this angle, and that is relative to direction east. So that is easterly in that direction. We're looking up from east, so that would be 30 degrees north of east. Meaning we're looking east and then going 30 degrees north of it. This is where understanding vectors helps. So let's call this vector A. Vector A is 94 newtons at an angle of 34 degrees north of east. You can add this to another vector by using what's known as the tip-to-tail method. So let's say we have a vector B. In B, we're going to just go straight north. And let's say its length, I can even measure it here. 32 newtons. So it'd be like having 2 forces acting on a single object. You want to add those 2 forces together, you need to add vectors A and B. And how do you do it? Well, let's pick a starting point. What we find with vectors is it doesn't matter where you start, because you can move a vector. You can move a vector wherever you want. You can start it wherever you want. It's the same vector, but you cannot change its size or its direction. So if I want to add vectors A to B, I can use the tip-to-tail method. So if I start here, I can draw vector B like this. And then when vector B ends, I start vector A. So that's B, and that's A. If I'm doing this carefully, I'm measuring to make sure that this is exactly the same size as that, and A is exactly the same size as that, and that this is also 30 degrees, and this is also straight north. That's what you ideally want to do. And then you get to an ending point here. So that's your end. That's your start. And you want to find out what the result of adding A plus B is. Well, to do that, we just find what's called a resultant. And the resultant is a vector that goes from the start all the way to the end. That's your resultant. And you can measure the length of this. And if you measure the length of this, you can turn it into newtons, for example. And you can find the angle here. I'm not going to do it now because I'm not 100% sure that I measured these exactly. I didn't measure them, so they're probably not quite the right line. But you can measure the length of the resultant, and you can measure the angle of the resultant, and that will give you the actual resultant. So maybe the resultant is 120 newtons, and the angle is 50 degrees or something like that. So the result would be like 120 newtons and an angle of 50 degrees north of east. That is one way to add vectors. There's another way to add vectors, and that's a mathematical way. And I'm going to talk about that in, I think, a minute. You can also reverse this result, and you get the same thing. So let's say you decided to start at the same place, or even a different place, doesn't matter. The idea is that you can apply 32 newtons of force directly, straight, and 94 newtons of force at an angle of 30 degrees. You can apply them to different objects. So you can apply it to a chair and a desk. And no matter which object you're applying it to, the sum of those forces, the total, is exactly the same. So let's say I pick a different starting point here, and I'm going to add A plus B. Well, I can do it graphically by going A, B, switching the order of them, And what I find is that the resultant R is exactly the same. So you get the same resultant regardless of order. So order doesn't matter. So we can actually say then that the resultant R is the result of A plus B, or B plus A. Now it actually turns out the resultant can be made with a bunch of other vectors. There's other vectors that would give you the same resultant. So maybe I have a resultant. That resultant could be made up of the same vectors or different vectors. So maybe there's a vectors, I don't know, X and Y. And that's what they look like. They give me the same resultant. So A plus B equals X plus Y equals R. So A plus B is going to equal your resultant, but it's also equal to X plus Y in this case. Or you could rearrange it and get different ones. I'm going to stop now because we have a different video that you're going to see in just a minute on the component method using vectors, which is another way of finding the sum of vectors, but looking at vector components. And for that, you need to use trigonometry. So this is the end of the first vectors video.